Hello everyone, in this particular video we're going to talk about properties of logs, and you're going to kind of see that they're very similar to properties of exponents that you've dealt with in the past. And so we're going to split this up into 3 different videos just because I don't want you to have to go through one big giant video. So I'm going to create this into these properties of logs video is going to be a 4-part series here, with each video being between 3 to 4 minutes apiece, so just so that you hopefully can get a good understanding. So we're going to talk about properties of logs. Before we get started, I want you to consider these prerequisites. These are properties that we are just assuming as we get started, as we deal with the properties of logs. So our logarithm properties, as you're going to see here in a minute, it's going to say for any positive a, the b must also be positive. B can't equal -1. M's got to be greater than 0. N's got to be greater than 0. And k can belong to the group of real numbers. And the reason I'm doing this is I'm going to show you these properties. And in the general property, you're going to see all of these letters. Okay, so just get ready. We're going to get ready to jump in here. Okay, so we're going to talk about the exponents product rule before we talk about the logarithm product rule, because the two very much work hand in hand. And so in this case, if you see a problem that looks like this, 2 to the power of 6 times 2 to the power of 4, and I told you that I wanted you to solve that or simplify that expression down to its simplest form, whatever the case might be. One of the things that you might do is say that it's equal to 2 times 2, and I'm doing this all the way out to, you can see there's going to end up being 2 tens, because I've got 2 to the 6th power. That's 2 times 2 times 2 times 2, 6 times, right? 1, 2, 3, 4, 5, 6. And then I've got it times 2 to the 4th power. That's where the rest of the 2's are. Okay. And so if I was to work that out, I would get 2 to the 10th power. That would be a quicker way to express that. But the product rule of exponents basically means if I'm multiplying 2 numbers with the same base together, then I can just add their exponents instead of having to go through the whole writing up the 2 10 times, 2 times 2 times 2 times 2 anyway. Okay. So I want you to remember that as we talk about the product rule for logs. Logs, by the way, is short for the word logarithm. So here's my property for products of logs, okay? Any log base b of a number m plus log base b of a number n is equal to the log base b of the product m times n. And so I'm going to let you look at this particular one right here. The log base 5 of 12. That's how you would say that, by the way, okay? So you say log, and then whatever number is in between the number with the parentheses, you say log base, whatever that number is, and then you say of, and then whatever the number is that you see there. And so as we take a look right here, before I get started, I want you to think about, well, what are my multiplication factors 12? And I don't want you to include 12 and 1, because remember, we don't want our b value to be equal to 1 here in this case. So I don't want you to include 12 and 1, and I have reasons for that as well right now, just because I want you to see the properties. Later, you can think about factors involving 1, but just for right now, we're not going to do it. Okay, so let's think about our factors. If we say, well, we know that 3 and 4 is a factor of 12, well, that means that I can say the log base 5 of 3 plus the log base 5 of 4, that's equal to the log base 5 of 3 times 4. And so what that means is, let's take a look at this one. I know you can't see that, but I said 6 and 2. 6 and 2 right there. But the log base 5 of 6 plus the log base 5 of 2, well, that's equal to the log base 5 of 6 times 2. And the reason that I'm showing you these here, and so I know that the log base 5 of 3 plus the log base 5 of 4, I know that that's equal to the log base 5 of 6 plus the log base 5 of 2, but all of these are equal to the log base 5 of 12. So basically, to make a long story short here, when we're doing the product rule of logarithms, multiplying 2 logs together that have the same base is the same as adding them together, according to this property. Now, what I'd like you to do on this next question here is I've got a series of logarithmic expressions. I want you to select all of the expressions that are equivalent to log base 7 of 36. Go ahead and do that now. And by the way, you'll see a link onto the next video in the series down below. So feel free to click on that if you would like to do that now as well.